we have learned in the previous section, there are two types of optimizer. One is the rule-based optimizer to RDO versus the CDO, course-based optimizer. So most of the relational database management system, they support both of them. So we can see the example of Oracle. This is our same overview as what you learned in the classroom. Okay. For rule-based optimizer, the query optimizer does not use the statistical information. Instead, they try to apply the flight-oriented rules to decide the path. For example, when you driving from Bridgeport to Manhattan, if there exists a highway, you will always select the highway. Okay, but it doesn't guarantee the driving through the highway is the fastest one. But generally, the highway is faster than the local road. Okay. Similarly, we can apply the same rule to decide the best path in the relational database management system. Specifically, the Oracle that is such a rule-based optimizer for Oracle 6, which is almost the first commercialized version of the relational database management system in Oracle. As I mentioned, probably before, the Oracle was commercialized. So once somehow the researcher in IBM Armada Research Center, they quit the job from the IBM, then they founded Oracle system because they believe at that time the IBM gave up to support the relational database management system hard project. So instead they tried to build their own company to commercialize the relational database management system. They developed until the version 5, and the Oracle 6 is the first popularly used commercialized version. Also, I learned the Oracle database from the Oracle 6 point something. Okay. Interestingly, the main architecture of the Oracle is 99% same as the current 12C. Current version is called the 12C. C stands for cloud, something like that. The main core part of the engine of the Oracle current version is almost the same as the Oracle 6. How much difference?
Yes, so why did
That's how I still survive. Because even though I learned the Oracle command and Oracle relational database since Oracle 6, still I can use the Oracle 12C. That's actually the interesting point. The reason is that anyway, the relational database use the concept of relation that you learn. It cannot be changed. So even though also there exists the standard for the relational database models, especially for SQL. So even though right now since 2003 there is not free for the standard, so everybody use the same standard. It's not much difference. Anyway. So that is a rule-based optimizer. As I said, that there are 15 rules, okay, in Oracle IDO. First one is row ID. Row ID is kind of the pointer. That is the fastest way to access the data. However, nobody uses the row ID in their query. But if you know, you can use the query. Row ID is 12-digit, a certain weird number. But nobody actually uses. But if you know that number, that is the fastest way. So if you can find the cluster join, if you can, your query includes such a cluster join, you can apply the cluster join the next one. Otherwise, apply this one. If possible, you can apply this. Eventually, the last option is a full table scan. That doesn't mean the full table scan is the slowest way to access the data. No. Okay, it depends. Sometimes the full table scan is faster than using index. That's a common mistake of the database developer. Most of the database developer, they try to enhance their query performance by adding index. Okay, but sometimes that may degrade the performance. Think about you have the 100 indexes in one table, which means whenever you insert one data, 100 indexes should be updated. Whenever your one index is updated, it should be sorted. As we have seen the B3 index, B plus 2 index, it should follow such a path. Also, you are implementing the B3 index, so they apply such an algorithm whenever data is inserted. Only one data inserted, the time 100 indexes should be the changing. That degrade the performance of your system. So this part, however, the benefit of using the RBO is what? Simple. Okay? You don't have to worry about the 2,000 different cases and the computer very complicated. Even for Oracle engine, it takes some time to compute all the. Also, CBO is the best one, better than RBO. No, you cannot say such a thing. We will see it later. So anyway, this is RBO, and using RBO query optimizer provide the execution plan. The output of Oracle query optimizer. Output of Oracle query optimizer is execution plan. Okay, you will see the data in your exercise. You will see sometimes using index. Okay, sometimes the full table scan, so nested join, or full table scan of employee, and using index and full table scan, or the accessing table. So most inside the index is the first one, then going out. So that is the execution plan. By following execution plan, the Oracle engine will retrieve the data and then return to the retrieve the data to client. The problem of the RBO is definitely it doesn't consider the status of your data. Okay, depending on the size of the table, as we have seen the couple of examples, it can be different. The weight, just like when you're driving from the Bridgeport to Manhattan, there are a bunch of different the condition, the traffic, weather, and how many people are going, and so on. So can we consider such a thing? That is the idea of CBO, cost-based optimizer. We will compute the cost based on the how many input and output, especially for the physical input and output. Okay, that is much intelligent way. Okay. They collect such information from such a catalog table. Okay. Sometimes if you do not have the permission, you cannot see directly such information. But the Oracle Query Optimizer has the administrative permission. So during your exercise when you have the permission to access data, you can see such information. For example, the DBM number tables has all the information about the table, including number of rows, number of blocks, and how many empty blocks, and average space, and chain count means how many rows are chained. Do you remember that? There are two options to use the block. One is unchained, another one is chained, which means span, unspan. So if the span, the row is a lot, even though you need the 20 byte, it will be point. There will be pointer and connected. That is called the chain. That is also another one important thing. Why? If all the rows are chained, you need double of IOs because you need to access two blocks to access one data. Okay? So and so on. And for example, if you need more information about a column to complete the course, you can access the tab under a column that has the kind of statistic like the histogram data based on the data, like the how many computer science major, how many the E major, how many TMA major, and so on. And also we need the indexes, like the level and so on. Using such information, as we have seen the before last class, we can use the cost function. And we will select the Oracle optimizer. We will select the lowest cost path for their execution plan. Okay. Also, they provide some more cost information. Not only just the I/O, actually they provide the most. You will see several examples of such a thing. For example, DB on the file and multi-block read count means how many data are continuously read by the Oracle engine in case of full table scale. That's much better than the scatter. Okay? And also in case of hash and sort area, there are many other. So also you will see the information about such a cost-based optimizer when you execute the query. So you will see during the exercise lab, like how many IOs from cache, how many IOs from hard disk drive. That's totally different. Even though your cost function is correct, if data are cached, that will be faster, right? So you can see such a difference. And same thing from index and so on. Also, Oracle Query Optimizer provide the CPU cost also. That is also important, but during the lecture, we actually ignore such a thing, but you will see such a CPU cost in the output of Oracle Query Optimizer. We already see such a thing. However, CPU also has the power. It cannot guarantee 100% fast pass. Lawfully, the user, Oracle user, said 70 to 75% are correct. But the other 20 to 25%, around the quarter, 1 out of 4 query are actually not the best optimized one. Okay? Which means there might be better way if you know the way solution. Okay? So for example, I developed the system, optimized system to find the route fastest way. My GPS is the best one. So find the best. It's intelligent system. It can consider weather condition and traffic condition and all the condition, but accuracy is 75%. One of the 4 route is not the best test. At the time you can guide. I try to go this way, I know the fastest way. Then similarly, Oracle support such a user interaction, okay, to guide. In other words, to give the hint to find the fastest way, which is called a hint. Okay, so you can use such a hint. If you believe this is the better way, faster way, then Oracle Query Optimizer CBO output. Then you can override such output of Query Optimizer using hint command. Okay, so I'm not going to explain details. So it will take, I think, several days to explain about only hint. Okay, but if you keep your mind, there is a way to override the output of Oracle Query Optimizer, which is the hint. You can later check and apply such a thing. So these are the hints that you can use. Why don't you use the full table scale? Why don't you use the row ID scale? Why don't you use the cluster index, ascending, descending? Why don't you join with the index only? Something like that. And there are more hints to override the query optimizer. Okay. Okay, that's the optimizer used in Oracle Query Optimizer. To practice such a query optimizer, you will have a chance on Tuesday to see the output of Oracle Query Optimizer and the example of the sample, another sample of the rule-based query optimizer, and how can you change between the rule-based optimizer and cost-based optimizer. Okay, then for the last topic, we will talk about the transaction control in the database. I'd like to cover the more topics in the advanced database course, but several years ago, the department actually combined the undergraduate database with the graduate level database course. So this is actually the course listed course 450 and 550. 450 and 551, right? So for graduate student it's a 551, for undergraduate it's a 450. But I still believe it should be separated. So unfortunately the department does not allow me to separate the course yet until we have enough in the database course. But if I have, that's the reason I cannot set aside the database design, which need more time to design and practice. Okay? So if I have a time for the advanced topics in the database, we can actually really build not only just the implementing the indexing structure, but we can implement the blocking, block-based data file and the indexing structure and input and output. Then even we can implement a query, the interpreter, select from where. Then eventually that will be the DBMSI, Relational Database Management System. I did a couple of times for such a thing. It was very nice, but you can find the YouTube video that we implemented several years ago. It's a very simple relational database implemented in this class by the undergraduate student. Actually, there was an undergraduate student in the class. Okay, so for the last topic, we will talk about the transaction control. Before that, wait, do you have the number and my face? Alright, just one. Thank you. So what is this? Computer. It's a computer, right? Server. So that we need operating system to utilize the computer resource of this system. And finally, we have the relational database management system. This is the application program. It's a DBMS. Okay? And this one has, so when you start up, okay? When you start up the database, okay? It's different from the starting your operating system, okay? So when you start up your database, you think what happened? This is the application program. Anyway, it needs what? Process. Execution means always process, creating the process. So when you double click what the type your command, what happened for your application? It copy, okay? Copy what? Your execution file, which has the set of instruction to the memory. Where? How?
In a process using a process control.
Your process will for an exe function. What does that mean for?
Creating process
Clone, make the clone. Okay? Then copy the instruction to the memory area. Okay?
Put the program.
Then exe means it's a separate, but still it's my children. Okay? Sometimes you can disconnect such a relationship. The parent ID, parent process ID will be 1. Then at that time, even though you log out, your children process is still running. Okay? That is a service program, like the web server. Web server, after you start the web server, you can log out, right? Their parent ID is 1. It's not zombie process. Usually zombie process has there is no parents, it's just 1, right? So, however, similarly, when you start the database, there are many, not only just one, many processes created. Their parent process is the system 1. Okay, even though you log out, it's still running. Okay, so each process has their role. And the DB writer is in charge of writing, and log writer is in charge of database log writing, and so on. There's also server-side process to listen the client request, just like the CS environment, okay, like the web server. You have the web server and web client, like your application program that you implemented using .NET or whatever, or even MS Explorer, Internet Explorer is a client. Then through the specific port 80 or 8080 whatever, then you can request the HTML file and return same thing. It's a listener. Okay? And in your client, sometimes laptop, computer, the other server can request through the 1520 and 4 with the TCP/IP and also database instance name. There's a database name over here. One more thing, in addition to creating the process, the database need one more step, that is reserve specific area of memory. Sometimes it's called the SGA, sometimes it's reserved. So SGA, System Global Area, anyway, it's reserved for only database. Why? What is the main purpose of such a reserved area? Cache. That cache to speed up. That cache is used for what? Data cache, even SQL cache, and the catalog cache, any type of cache to speed up. Okay? This area is reserved. Okay? So when you connect the database through here, the listener is the exactly same as the web server. Exactly same as FTP server. It's a client server environment. Their network connection is exactly the same thing. When you have the client request, just like when you log on to the remote database, they listen then create the process. Okay? Create the process to handle such a request. Then access sometimes the memory, hard disk drive. So who will submit the query? So we discussed about what it happens when you submit the query. Query optimizer will scan, parse, validating, and eventually decide the execution plan and return the data. Okay. So I'd like to give one example. So there is an employee table. This is the data one. Okay. Employee table has the data one ID. So I'd like to update. Update employee ID 1 to 2. So I'd like to update 1 to 2. What happened? First, you need to read the data to update. Okay? So query optimizer also is working to find the best path. Whether full table scan is faster or the primary key is exactly same as the select. Then find the path and read the data and update 1 to 2. No. Okay? It doesn't update the data in the hard disk drive. Instead, always read the data from the memory first. For what? Speed up. Okay? So we can read the copy this data into the memory. So right now in the memory is the 1. What's the size of this rectangle? What is that?
The block.
It's a block, database block. It can be 2K, it can be 4K, it can be 16K. Sometimes it's a 64 megabyte, depends on your setting. Okay? So even though you update the 1 byte, the entire block will be loaded. So after load, database will update. This one is 2. Yes? No. You cannot update this block directly. Why? Why? I'd like to update the data. Then what's the problem? What's wrong if I update this one?
Referential integrity. Referential integrity.
Referential integrity? Then why don't we apply the cascade? There's no foreign key. It's related. What if somebody access the same data, ID, and try to read the data, but is it 1 or 2? Should be 1. It's supposed to be 1. Why? Because it's updating now. Even though data is updated, it's only for this one. We don't know whether this is finalized or not. When then? If not finalized, when can be finalized? How can we decide? Okay? So at that time, we need to take care of such a problem. That is for transaction. So we need to use the concept of the transaction that you learn in operating system. So exactly same idea. What is a transaction in your operating system? Are you going to take? Who is taking the operating system? I think that will be the question of your midterm or final. What is the transaction? Nobody take? I think it's a course. What is a transaction? It's a logical unit of operation. A set of operation, but it's a logical unit and should be autonomous, which means it cannot be divided into two places. Which means, in other words, once this transaction is started, it should be either abort or commit. Either of them. In case of abort, all change of the data should be go back, revoke. Okay? Otherwise, commit means apply permanently. That is a transaction. It's the same thing. So this transaction is not completed. In other words, committed. So that is the reason when you update your data, you must commit. Okay? But when you are doing the programming, you never commit. Right? It's automatically committed when your query is done. Okay? That's sometimes you may not realize. But your database administrator change the option. This server, each and all the transaction must explicitly commit. Then at the time you need to do that. But as a default, you don't have to. Also, especially when you are using the C++ application, when you log out, it can be either auto commit or go back to original. But as a default right now, it's a automatically. But in the middle of a session, you need to, until committed, it should supposed to be one for the other. So, to support that, we can actually copy and say this is a before image and after image. Okay? Then, before commit, all the other transactions will access before. And this one will access after. Once committed, this one will, we don't need this one. Then the other transaction will access this one. But I cannot believe this even though committed. Why?
Somebody tried to update it.
Same time, not possible. We will see.
It was already
When you update the data, it should be locked. Okay, we will see. But there is a transaction, another transaction. It starts before commit, still accessing the data. Like the sum of ID, it takes 10 hours. In the middle of that, commit. Yes, it can commit. So 2, we cannot do it. It should be 1 until this transaction is finalized. How can we support transaction? The transaction. So one more thing. So it's a permanently applied. So right now it's committed, it's a 2. What about this one? Is it 2 or 1? When you commit the data. So commit. Commit means permanently apply. And is it 2 or 1? 2. Unfortunately, it's 1. In the hard disk. Why? That's my question. You commit, so it should be 2, right? But it's 1. Why? Original, you don't need the original data because commit. Because of performance. Writing hard disk drive is much slower than memory. So whenever you change the data, if you change hard disk drive, your system will be too many I/O way. In your operating system again, you learn what is I/O way. CPU, when CPU need to access the data, read the data, interrupt, stop, and wait until this controller return the data. It takes a long time. That's the reason at that time, CPU will do the other instruction. Who is controlling such a thing? CPU's test. Okay? So, this time, when transaction is committed, it should be 2, but it's still 1. When it's gonna be changed? When system is idle or enough resource from time to time. Not every time, at certain time. It's called delayed writing. Delayed writing? There's another name, I forgot. Anyway, it's a delayed writing. So we will see. Anyway, it's somewhere in the slide. Okay? Delayed. The meaning is delayed writing. Anyway, it's a delayed writing. Okay? So not every time, it's every other second where something happens. Okay? Why? To increase the performance. The problem, this is another question. So it's a change on the memory, but not yet hard disk drive. Okay, but it's committed. Unfortunately, so this is what? This is in the memory too, then it's committed. Somebody pull out power cable. Okay, which means system is down, it's crashed. Then what happened? Is it 1 or 2?
1.
When you restart the system, either 1 or 2. 1, 2. If 1, you cannot sell your DBM because it should be 2, right? But it's a 1. So, because it's a memory all the time, it will be gone without power. But it's still in the memory. So, to address that problem, we need transaction. And transaction is not for that. Transaction also used for recovery. Okay? Not only for consistency, it's used for recovery. Let me show you how it works. Briefly. When you start up, there is a log file. Okay? That log file keep all the action in your database management system. Actually, when transaction is finalized, it's not commit. After commit, there is one more action. You need to write your action to the log. I update 1, 2, 2, like a command. This is in the memory or hard disk drive. It's actually in the memory also. Because of what?
So it will be gone.
Cache. So transaction will not be finalized until this is flushed to the hard disk drive. first write to the memory, then hard disk drive. This is called read log buffer. This one is read log. Okay? So, which means when you start up system, your system will check this one log, whether this command is applied or not. If not, this is supposed to be 2, but it's 1. At that time, you need to redo. So it's a redo operation. So it will be changed into 2 when you start up the system. This is called instance recovery. There is a similar approach is undo. Undo means sometimes your database is supposed to be 1, but hard disk drive is changed into 2. When you update huge amount of data, you cannot keep all before and after image in the memory. Memory is limited. So they actually update the data here, even though it's not committed. So when system crashes, check the command. This is supposed to be 1, but it's right now 2. You need to go back, undo operation, roll back. Okay? So this is the overview of the data consistency, transaction control, and backup and recovery. Okay? So we will see details of that throughout this lecture. Any question? Yes.
For this case, you said that the log file is on memory. So when the
Log file is not memory. There is a memory area to keep the log information first, then flush it out such a memory data to the log file. That will be transaction will be finalized.
So when the electricity was applied, then the log file
If-
is done.
If this is in the log, but not log file, which means this transaction is not done yet. Commit is not applied. Okay, at the time, this one should be, in case it's changed, undo, otherwise just start. Not redo. That is called write ahead log. This is called write ahead log for recovery purpose. So, we need a transaction management because it's a multi-user system like that. Okay? So actually the SQL Server in Microsoft, it was the single user system like their operating system long time before. The Windows 33.1, what was, and the 95, it's only single user system. Their SQL Server was the same. But they realized they need to support the multi-user system. To do that, they need transaction management. Instead of developing their own transaction management, it's a little bit complicated and they don't want to waste of time for some database management system. Instead, they actually buy the transaction manager from Sybase. So actually, the Sybase and the Microsoft, the SQL Server, their transaction management are the same. Anyway, so transaction is a logical unit of the database that includes one or more access operation. It's a logical unit, so it's a basic unit, so which means it cannot be divided into 2. All database transaction begin with begin transaction and end with end transaction. Have you ever used that one? Sometimes you use in the database program, but most of the time, no. What about the SQL Plus? Do you type begin transaction or end transaction? Even though you do not type, whenever you log in, automatically begin transaction. When you log out, it's an end transaction. Programming is the library is same. Okay, always begin and end transaction. So we can say there are 2 operations, main operation, read and write. Update, delete, write, and put, update, write. With insert, also write. And select is the read. So we can say there are 2 main operations, read and write. The time X means it's a data item. Data item can be field, or record, or entire table, entire user, entire database. support the granularity, so it can be anything, database object. So when you read the data, I already explained. When you read the data, it copy the block into the memory and read the data. In case there exists the memory, the data block in the memory, you don't have to read again. That is a read operation. That is the copy item X from the buffer to program the resident X they use if there exists the data in the memory data block actually. Right. When you write the data, it's the same thing when you read. If there is no data item over here, they read it and modify. But that may cause a problem, so because of that, we need to consider transaction. Without concurrence control, we want to, in case of a multi-user system, we want concurrent. The system should be able to support concurrent user, which means multiple users can access the same data item without such a concurrence control. There are problems. Okay, so first one is a loss update problem. This is the same thing. Okay. When you modify a transaction, modify the data, if you do not have such a transaction concept, concurrence control, the other, okay, whether it's a change it or not. And temporary update is the same thing. So when you have a long query without such a concurrence control, in the middle of transaction, it can be changed there. If you wanna develop the database management system, simple and perfect system, you can use R actually. Whenever you read the data, whenever you update the data, you can lock the item. Then once transaction is completed, you can release the lock. That is the best way. However, that is not the best one in terms of what? Speed, performance. All the other transactions should wait until the lock is released. That is the reason we need such a concurrence control. Also recovery. So there are different types of recovery. Comes the failure, system break, unplug the power. Okay. Or even sometimes transaction will be error because of network failure. Okay? And there are virtual. So transaction. That is also crash. And exception, okay, as a programming. And concurrence control enforced concurrency management cannot handle complicated cases. Then send an error. So at that time we need to recover the system based on what? Transaction. Concept of the transaction. Even for physical failure, including physical failure and other. So in transaction is a logical unit and also atomic. It cannot be divided and it cannot be further. So there are states for the transaction: active, start, begin transaction, and end transaction. Either it can be commit or abort. In case of abort or change the value should be go back to original, otherwise it's permanently applied. Permanently does not mean update to hard disk right now. Logically permanently update. Okay? And even you can partially commit the data. It's called a checkpoint. You can use a checkpoint. So your transaction start here to end here, but I want to apply this part. Then there's a checkpoint A and checkpoint B. Sometimes you can go back only specific point, checkpoint A. And the other, this one will be applied. That is a partially committed. Okay. So begin transaction and transaction. Okay. Commit means permanently apply. Abort means rollback. All changed value will go back to the original. There are two operations for recovery. As I said, undo and redo. Undo means it's applied, committed, but not applied to a hard disk drive when the system is recovered. So at the time, we need to read that operation. Undo means it's supposed to be 1, but in hard disk drive 2. Why? Because of the transaction control. This value can be changed without commit. Okay? But logically, it should be 1. So at the time, you need to undo, go back to the original when system is recovered. How can you manage, how can you implement such a thing? With the log data. So this is the log. So, or sometimes it's called the journal. So that log information includes such an entry. Okay? When the transaction is started, what is the operation, right? Update, whatever. And what is the item, what is the old value, what is the new value. And in case of read, who each transaction are reading the data and commit and avert. So such an information should be logged. This log data will be used for recovery. And this is a reason. You know, everybody knows backup and recovery is very important. Also, you should know what data should be backup. Okay? Sometimes if you join any project, right now the even small size company, they have the petabyte size database. Copy entire system every day doesn't make sense. That's more. Even though you copy entire system, logically it should be perfect. Logically means because database has their own data structure, even though you have all the file, unless you have the image copy at certain point. That's also problem. This is a time you have the image copy of midnight. And system crash at 1 a.m. You cannot recover this. It's not real time. Okay? Not real time. There's a specific number. Today I forgot the many of the half backup, quarter backup, something recovered. But anyway, you cannot perfect. You may lose such information, even though you have the images at certain point. Database is still keep running, keep changing. How can you back the restore up to the failure point? You need to back up log data. As long as you have the log, you can recover. Okay? So that is the most important one. Not for you, for database administrator. Yesterday, I met one of the students who worked for the company in the Dartford. His team has a database administrator. Their database administrator DBA are the most busy job. They usually have a meeting 9 to almost 4 or 5 p.m. Then they start the job after the meeting and until midnight. So that's the usual for database administrator. And also they need to take care of the data swap, the database design. Whenever the application developer requests to change the system, they need to test first whether there is a problem on the existing. For example, I'd like to remove the column A, which is supposed not to be used, but who knows? There are old applications that access the column A. So you need to test. Even though it's successful in the testing system, you need to wait the time until after you apply the permanently. You need to wait whether the change is okay or not. Also, you need to wait the operator call the midnight. Once there's a failure or problem, your operator will call you, not operator. It's just monitoring the system. So that is a system law. I'm not going to explain details how to use the law, but basic concept is redo and undo. So because of that, so we can recover the system. So backup the raw data is the most important in the database administrator. So for the transaction, there are 4 ACID well-known properties. One is automaticity. So transaction should be atomic, consistent preservation. So correct execution of the transaction must change the state, one consistent state to another consistent state. Okay. So in simply currently the system is perfect. Okay. Then once you apply the commit or the abort or the end transaction, the next database state should be perfect. So that is a consistent preservation. Isolation is a transaction should have the isolation level. They cannot be bothered from other transaction. However, there is the level. For example, if you have 100% isolated transaction, when you read the data item, this one, nobody can access. So entirely isolated. That means the system should be hanged. First, wait until this transaction is, this item is released. So you need to have different level of isolation. Also, there should be durability and the performance.